we now know that a polynomial is one that has more than one monomial in it. It could also just be a monomial, but it has one or more terms in it. And we're going to multiply these together. Basically, we're just going to be using the distributive property and taking it to a different level. Okay. Where's my little page turner? Here it is. Okay, so like I just said, to multiply a polynomial by a monomial, you're going to use the distributive property. Oh, please. Distributive property. Here we go. We have negative 3x squared, and we're going to distribute it into this entire phrase inside the parentheses. All right? So we'll rewrite our problem, and we're going to do negative x. Well, please. That'll make you dizzy. We're going to do this times this, this times this, and this times this. And you'll see that's exactly what they've done in our sample problem. Negative 3x squared times the 7x squared, right? And then we're going to take negative 3x times the x, and then negative 3x squared times the 4. And actually multiply that out, and you get negative 21x to the 4th minus a minus 3x cubed plus a negative 12x squared. And then you simplify these. This stays the same. Negative times a negative makes a positive 3x cubed, and plus a minus makes a negative 12x squared. So you can see by this point you have to be comfortable multiplying your exponents. You have to be comfortable adding and subtracting your positive and negative numbers, okay? All right, here are two problems for you to practice on. We'll pick two lucky folks to go up and put these on the board for us on Monday. Pause it, do them, start it back up. Okay, you can use the same method more than once to simplify larger expressions. So here we have two things to distribute, right? We have 2p, and we're going to distribute that into negative 4p squared plus 5p. And then we're going to subtract 5, which has to be distributed into 2p squared plus 20. All right. My first step, if I wanted, now let's just leave it like that. Okay, so that was our first step, is to write that. Now let's distribute 2p times negative 4p squared, right? We have to multiply those two together. Plus we have to multiply 2p times 5p. Okay, we got that guy taken care of. Now we have to multiply 5 times 2p, and we have to multiply, I'm going to think of this as a negative. Everybody comfortable with this idea? Everybody knows that we can change that to plus a negative 5, right? Everybody understands that. So let's go ahead and do that. Let's get our positive. Let's go ahead and add these two together right now. So negative 5 times 2p, and then plus negative 5 times 20. All right, and now we simplify that, multiply this out, we get negative 8p to the third plus 10p squared plus negative 10p minus, did I do something wrong here? Did I copy the problem wrong? Nope. Oh, this is p squared right here, someplace. Right there, I need a p squared. So that's minus 10p squared minus 100. All right, I notice that I have a plus 10p squared plus a negative 10p squared. Guess what? Goodbye. Those two are gone. That makes life a little easier. So now we only have 8p, negative 8p to the third minus 100. There's our answer. All right? Here's some for you guys to do. Again, pause your video. And again, we will pick 2 lucky winners to come on down and put them on the board. Good luck. Okay, here we have a standardized test example problem. The theme for a school dance is called solid gold. So they're decorating poster board to make it look like gold bars. So say, okay, so for one direct decoration, Kana is covering a trapezoid. This is a trapezoid, right guys? Right here, the trapezoid, right? 2 bases and it has a height, you'll remember. They're going to cover that trapezoid sheet of paper with metallic gold paper to make it look like the gold bar. If the height of the poster board is 18 inches, how much metallic paper will Kana need in square inches? Okay, so what you have to remember is, okay, we have to find the area of the poster board, of the piece of poster board, so we know how much metallic paper she needs. So we'll take that formula for the area of a trapezoid, A equals 1/2 the height times base 1 plus base 2. And that you probably won't remember, and usually on most standardized tests, they will give you that formula to use. Okay, let's see if we can apply this. So let me remind you that this is base 1 and this is base 2. It really doesn't matter which is which, but you got to understand that one of these is this and one of these is this, and we know the height is 18. All right? Okay, let's see if we can put that into our formula that we know for area of a trapezoid. All right. So, whoops. So we have A equals 1/2 the height, and we know base 1 is this, 2h minus 4, plus, I could even have done it as a bracket, right? The other base, which is h plus 1, parentheses and bracket. So A equals 1/2 the height. Now we have to work out inside the brackets here, right? So we're going to have 2h plus h is 3h, right? And negative 4, I'm sorry, this is a positive 4. I can't read that. That's a plus 4, believe it or not. 4 plus 1 is going to be 5. All right? Now let's distribute. A equals 1/2 h times 3h plus 1/2 h times 5. So that gives us A equals 3 over 2 h squared plus 5 over 2h. I'm going to extend our page, and you'll see, excuse me, there we go, extended page. All right, so now we know that h is 18, so we can substitute in A equals 3 over 2 times 18 squared plus 5 over 2 times 18. And if you do some math on your calculator, you would find out that the area is 531 square inches, I assume. Okay? All right, let's move on. Because I think you get to try one of these, you lucky guys. Here it is. We have triangular bandanas for dogs and cats in the pet club. Let's read through this together. I'm going to let you figure out how to work it out, but I'll read it with you. The base of the bandana is the length of the collar with 4 inches added to each tie on it. The height is half of the collar length. Okay, so if Kachima's dog collar has a collar length of 12 inches, how much fabric does she need in square inches? All right, so you have a triangle. Let's, draw yourself a picture. Figure out, it tells you what the base is of the length and what the height is. See if you can figure this out. And then do part B. Her friend has cat needs a 6-inch collar, so you're going to have to figure it out for that too. Okay, good luck with that, guys. All right. Now we're going to solve a little bit more complex polynomial expressions. This time we're going to have expressions on both sides of an equal sign. Okay, so there's a study tip up in the corner says that sometimes it's helpful to draw a circle around your like terms so that you find them all, and maybe to draw a square around all your other like terms or something like that. But see, if you need it, you can do that, but you may not need to do that. All right, so I'm going to slide this guy up a little bit now that we've read that study guide tip. Okay. All right, so we just have a little bit more room. Yeah, it looks like a long problem, doesn't it, Caden? What do you think? But I know you guys can all handle this now. Everybody is ready for this. Okay, we're going to distribute like crazy. So we're going to start with writing our problem so we see what we have. We have 2a parentheses 5a minus 2 plus 3a parentheses 2a plus 6 plus 8. And that's equal to a times 4a plus 1 plus 2a parentheses 6a minus 4 plus 5. That gives me a chance to really look at all the elements that are in this problem so I don't miss anything. And I'm going to be quite honest, when I first read this problem, I didn't realize there were quite so many things to distribute. Now I realize there really are 1, 2, 3, 4 things that I need to distribute. So let's do the distribute it. So 2a times 5a plus 2a times negative 2 plus 3a times 2a plus 3a times 6 plus 8 equals a times 4a plus a times 1 plus 2a times 6a plus 2a times negative 4 plus 50. Running out of room, right, guys? That's problem is way too long. Okay, let's make it shorter. 2a times 5a is 10a squared plus 2a minus 2 is minus 4a plus 3a times 2a is 6a squared plus 3a times 6 is 18a plus 8 equals a times 4a is 4a squared plus a times 1 is a plus 2a times 6a is 12a squared plus 2a minus 4 is negative 8a plus 50. Well, it got a little shorter, right, guys? Okay, where are our like terms? I'm going to use colored pencil for this. So we have 10a, we have an a squared here, we have an a squared here, we have an a squared here, we have an a squared here. Let's put all those beside each other. 10a squared plus 6a plus, oh, I can't do that. On one side, let's combine them. 10a squared plus 6a squared, okay? And then we also have plus negative 4a plus 18 plus 8 equals, let's move these two together, 4a squared plus 12a squared plus